Hello and welcome to my presentation. My presentation is Automated Invasive Animal Detection and Species Classification using Trail Camera Images and Convolutions. So, what is the project? Essentially, I'm using trail cameras to get images of animals, just single images of animals that are detected, and taking the photos that are taken of those animals, and then using those photos to create predictions and eventually create an actual recommendation based on the images collected. This project is more aimed toward farmers and people who have a concern with invasive animals. So why do we use trail cam footage? Well, trail cam footage, essentially it doesn't always record, so it only records when something is in front of it or if motion is detected, and so it reduces the total amount of non-usable footage. It results in reduced computational capacity or complexity because we don't have to constantly be filming like with a surveillance camera and constantly being doing um, surveillance or processing on the footage from the surveillance camera, and it's cheap. It's quite cheap in comparison to a surveillance network. Yeah, on the lower end of costing for farmers. So the dataset is a dataset that I created myself. I built it out of 140 images of 5 classes of animals. These are invasive animals that farmers do have problems with. They break into feed and they kill animals or they spread disease. And these classes are foxes, squirrels, rats, raccoons, and possums. So because the dataset is quite small, it's quite a limited dataset, I normalize all of the images to try and prevent overfitting. This is done where I actually in batches of 64 create sheared, zoomed, horizontally flipped images to just try and get a little bit of variance in the data. Um, okay, so this is the first pipeline, and this is a CNN that's been constructed completely from scratch. Essentially, it is just a bunch of convolutional layers with a bunch of max pooling layers to get it smaller, and then a flattening layer, and then a bunch of dense feed-forward layers, or a feed-forward neural network at the end, with the dropout layer right at the end to prevent overfitting. And as you can see, the model crosses over here at the beginning, and I choose the model that is at 10 epochs. So next I do for my second pipeline, I do transfer train CNN. This is a VGG16, and the last layer is set to trainable. Then it has a flattening layer, a dropout layer to prevent overfitting, and then it has a dense layer for output, softmax. And essentially, I train this, and this is how it does over time. And I take the model at 6 epochs. Or 5 epochs in this case, and that's the one that I use. So these are the hyperparameters that I chose. I find them using just using a grid search. Well, not a grid search, but the just the bottom grid. I follow each one of the batch sizes, changing the amount of epochs depending on what I need, sets of normalized data, train test split, and the amount of dropout I want to use. And based on the results of that, and on running them multiple times, I can determine which outputs are going to be the best, or which models are going to be the best based on their on their metrics. And these are the metrics of the results of the pipelines. Constructed CNN has a training accuracy of 29%, 30%, and then it has a validation accuracy of 40%, and then transfer trained one is 40% on training, but 50% of validation, and so it's quite a leap up from the constructed CNN. So VGG does perform better than my constructed CNN. So finally, I'm going to do a demonstration, and this will essentially tell me the confidence of it being that image, or being that class, and then it will tell me what it thinks it is. So let's look at that now. So over here is my project. It's quite small. But yeah, so essentially what I can do is I can upload an image, and we will pick just the squirrel that we saw, and there you can see the image has been uploaded, and I can click predict, and it will now run that image through both of my pipelines and gives me an output based on what it was. Okay, and now I'm going to predict an entire group of animals. Over here we can just go to the project, and we'll predict all of the rats. So we can run through every single one of these images, and it will make a prediction for every single one inside of this folder. This is for farmer ease of access, so they can actually run all the data for the night through the neural network, or through the convolutional neural network, and actually get responses on what the confidence level of the CNNs are to actually give that thing. So over here you can see there is disparity, but the vast majority of classifications are that is a rat. So it yeah, definitely knows that that's a rat. The chance for train 1 does have more confidence, but yeah. And then finally, now that I've run all that, I can do get recommendation, and it tells me the recommendation of what to do. Obviously the most common animal from the night, since we ran this program, was rats, and so the prediction is that it was all rats. Thank you very much for listening to my presentation. I hope you enjoyed.